So, good morning or good afternoon, everyone. I am here to discuss about our topic, and the title of our topic is Weather and Sea State, Interconnectedness, Navigation, Forecasting. So, first of all, before we start, I would like to introduce myself. I am Mitch Mansudosta of Group 5. So, here is the introduction. Weather and sea state are two of the most critical factors affecting maritime navigation and operations. Weather refers to the daily atmospheric conditions, including temperature, precipitation, wind, and humidity. Meanwhile, the sea state refers to the physical condition of the ocean surface shaped by wind, strength, wave patterns, and ocean currents. These two elements are deeply interconnected, influencing each other in dynamic and sometimes extreme ways. Understanding this relationship is fundamental for the safety of vessels, the efficiency of voyages, and the protection of maritime environments. So, we are going to proceed at the discussion, interconnectedness of weather and sea state. The sea state is primarily driven by atmospheric conditions. Wind, generated by difference in air pressure, transfers energy to the ocean surface, forming waves. Stronger winds create larger and more powerful waves, leading to rougher seas. Conversely, calm atmospheric conditions allow the sea surface to stabilize, resulting in gentler waves. Atmospheric pressure systems such as cyclones and anticyclones can be drastically alter sea states, with low pressure systems typically associated with turbulent seas. Ocean currents also influence regional weather patterns, affecting temperatures and fog formation along coasts. Importance for navigation. Mariners must be acutely aware of the weather and sea state before and during voyages. Rough seas can lead to increased risk of capsizing, mechanical failures, and cargo damage. Severe weather such as storms and hurricanes can threaten entire fleets if not properly anticipated. Accurate and timely information about current forecasted weather and sea conditions is crucial for planning safe and efficient navigation routes. Advance in forecasting. Modern meteorology and oceanography employ satellites, radar systems, buoy networks, and sophisticated numerical models to predict weather and sea conditions with increasing accuracy. High-resolution forecasts allow shipping companies to anticipate hazardous conditions, adjust routes, optimize fuel use, and ensure the safety of crew and cargo. Despite advances, forecasting still faces challenges in rapidly changing weather systems and unpredictable sea states requiring continuous monitoring. So here is the impact. Safety impact. Accurate forecasting is linked to maritime safety, helping avoiding accidents caused by sudden changes in weather and sea conditions. Economic impact. Weather delays and rerouting increase operational costs significantly. Environmental impact. Shipwrecks and oil spills caused by rough weather have devastating ecological effects. Logistical impact. Port operation depends on predictable schedules. Disruption for unexpected sea conditions cause congestions and financial losses. So here's the purpose. The purpose of this study is to illuminate the strong dynamic relationship between atmospheric and oceanic conditions. It emphasizes the necessity of continuous and accurate weather and sea state forecasting for all maritime activities, promote better technological integration and mariner education, and advocates for strategic planning based on comprehensive environmental assessment to enhance maritime safety and efficiency. Case study: the El Faro disaster. The sinking of the SS El Faro in October 2015 during Hurricane Joaquin highlights the danger posed by failing to account for weather and sea state. Despite reports of worsening conditions, the vessel continued into hurricane's path. Investigations revealed outdated weather data and misinterpretation of forecasts. The ship encountered 40-foot waves of hurricane-force winds, resulting in the loss of all 32 crew members. The disaster underscores the need of real-time updates, correct interpretation, and decisive action based on evolving forecasts. So we're going to proceed at the conclusion. Weather and sea state are dynamically linked, shaping every maritime journey. Understanding this link saves lives, cargo, and operational integrity. Modern forecasting tools and trained crews are the first line of defense. Constant vigilance, preparation, and adaptability based on real-time information are critical to maritime safety. So last recommendations: mariner training, implementing mandatory training, focusing on weather and sea state interpretation. Technology investment, equip vessels with modern real-time weather and sea state monitoring system. Voyage planning, require dynamic voyage planning with contingency routes. Agency collaboration, strengthen ties between meteorological agencies and maritime operators for faster information and dissemination. So the last is risk management. Develop onboard emergency protocols specific to sudden shifts in weather and sea conditions. So I hope all of you learned today, and I'm so grateful that all of you will listen. And I hope you have a great day on sailing voyage in sea. Have a great day.